In this video, I want to look at the idea of comparing integrals. So to get started, we are going to let f of x and g of x be continuous functions on the interval between a and b. And we are going to suppose that g of x is always less than or equal to f of x on that same interval between a and b. And my question is, what can we say about the two definite integrals, the integral from a to b of g of x and the integral from a to b of f of x? So that's what I'm actually going to be wanting to look at in this particular video. Well, let's actually consider some cases. If it turns out that g of x is at least as big as 0 and f of x is at least as big as g of x, then we get this kind of a picture. So let me get a decent enough xy axis, and let's see, g of x is going to do something, so let's draw g of x, I don't know, in this pretty little white color. Actually, I guess g of x is going to be yellow. And let's make f of x has to be bigger than this guy, so it might do something like that. So this is y is equal to f of x. And I want to get the endpoints of my integral. So there's a and there's b. And what I want to do is I'm going to actually shade in the area for each integral. Now, if I'm going all the way up to the f curve and all the way down to the axis, this white area, of course, is the integral between a and b of f of x dx. Now what I want to do is I want to shade in some yellow area. This yellow area, of course, is the integral between a and b of g of x dx. Now there's an obvious fact that's clear from this picture. The yellow area is completely inside the white area, so the yellow area is clearly less than or equal to the white area. And so what this says is that the integral between a and b of g of x has to be less than or equal to the integral from a to b of f of x dx. And as long as g is trapped between the x-axis and f of x, this fact is going to be true. Well, now what I want to do is I want to kind of think about what happens if the two functions are below the x-axis. So what about the case where I've got g of x is smaller than f of x, and f of x is going to be less than 0? Well, let's again think about drawing what's going on here. So here's my xy axis, and this time what I want to notice is that f of x is closer to the x-axis than g is, so I'm going to draw f first. So there is y is equal to f of x. And let's see, let's stick with the same colors that we had last time. G of x is smaller than f of x, which means that it's further away from the x-axis because everything is below 0. And so maybe it does something like this. So this is y is equal to g of x. And again, we need to have a and b. Now what I'm going to do is I'm going to shade in the two areas again, and I'm going to notice that my yellow area looks like this, And my white area looks like this. Now, in terms of plane area, not talking about integrals, that white area is certainly less than the yellow area. But in terms of plane integrals, in terms of plane area, everything is considered to be a positive number. And what I want to notice is that the integral between a and b of f of x dx is actually equal to minus the white area. And the integral from a to b of g of x dx is actually equal to minus the yellow area. And so what I want to do is I want to multiply this inequality over here by -1. And when I do, I'm going to get that 0 is going to be bigger than minus the white area, and the white area is going to be bigger than minus the yellow area. And in this particular case, that says that we have 0 is going to be bigger than, well, minus the white area is the integral for f of x. So we get the integral from a to b of f of x dx. And that's going to be bigger than the yellow area, and the yellow area is, rather than minus the yellow area, and minus the yellow area is the integral between a and b of g of x dx. And so here again, we're seeing that that the integral for g is indeed less than the integral for f of x. And I need to clean my handwriting up there. Now, the final case that we might have, which is worth looking at very briefly, is that it's possible that g of x might be smaller than 0, and 0 might be smaller than f of x. And in this particular case, we have a picture that would look like this. F of x would be up here, and y is equal to g of x would be down here. And when I shade in the colors, let's see, actually let me get my endpoints. So there is A, and there is B. And this white area, which is positive, is equal to the integral from a to b of f of x dx. That is the white area, and of course that's going to be bigger than 0. And when I shade in this yellow area, the yellow area is a positive area, and minus that yellow area would be equal to the integral for g of x. So the integral for g of x is minus the yellow area, and minus the yellow area is obviously less than 0. And so again, we're going to have that the negative area for g is clearly going to be less than the positive area for f of x. And so we get that we still have the integral from a to b of g of x is going to be less than the integral for f of x. So in conclusion, what we've seen here is that if g of x is less than or equal to f of x on an interval between a and b, then no matter which scenario we have, the integral for the g function will always be less than or equal to the integral for the f function. And this is a major theorem, and we want to make sure that it gets into your notes, and we'll look at an application of this theorem in the next video.